Okay, do you know that this is a fraction function? It's the fraction function, and technically there's a name for that. It's called a rational function. Your next test is all about rational functions. So obviously they must get harder from here. If you already, this was it, you'd already have it. 1 over x is this function. Okay, what's 1 over x squared look like? Well, if you had to, what's your best friend in graphing? XY chart. You could just make an XY chart and figure out how this looks. But I'll save us some time. When you put in the negatives is when it would really matter, because you get it, when I put in a negative, it's going to square it and it's going to become positive. And so it's like this. That's the 1 over x squared function. There's a whole bunch of functions that you're going to have to know. Yes, thank you for coming. So I do not need you to memorize the 1 over x squared function yet, but eventually you'll have to. Let me back up in time here and go back to this function, which is a little simpler. What we're going to do a lot of is make adjustments to this function and say like, oh, what if it was 1 over x plus 1? Do you get that would move the function? Now, did I just put that 1 on the, quote, inside? I think you should think of it this way. Inside is whatever is right by the x. Did I put that 1 right by the x? Then I put it on the inside. If I put it on the inside, that's an inside is horizontal on the inside. HIVO is the little acronym I've been using. Horizontal on the inside. That is a horizontal move. That just moved my graph. Where? Left 1. Now, when it moved to the left 1, something moved along with it that I haven't even got on the board, because technically it's not the graph. It's kind of like where the graph isn't. These guys. Remember those guys? There's horizontal and vertical asymptotes involved in this graph. Now, just a quick reminder, the one that goes up and down is like the y-axis. It's a little bit counterintuitive, though. That's x equals 0. Do you get why I'm going to be connecting the verticals with x? Because the vertical asymptotes are the x equals asymptotes. Does that make sense to you? This is the vertical one, and it's x equals. So I'm going to hence say zertical a lot. X-E-R-T-I-C-A-L. The zertical asymptotes. Why is that such a big deal? Because if I say what's the vertical asymptote and you think that's the y equals things, it's going to get all backwards and all messed up. Okay? It's zertical, and then this is the x-axis, also known as y equals 0, and that is not a vertical asymptote. That's going like this, like the woohoo. Sorry, I'm going to undo that, grab this thing. That is a vertical asymptote. This guy right here. No, it's not. Sorry, that's a horizontal asymptote right there. And that horizontal, I'm going to give the moniker horizontal. Get where I'm going with that. The y equals things are horizontal asymptotes. The x equals things are vertical asymptotes. So if a kid said, these are the two asymptotes, Mr. Server, x equals 3 and y equals -2, you'd need to be able to graph them and know what they were. Do you get the y ones are horizontal asymptotes, and the x equals ones are the zertical or x equals asymptotes? All right, would you please sketch where the asymptotes are? And then what we're going to try to get you to is be able to look at an equation and go, oh, the vertical asymptotes are this and the horizontal asymptotes are that. All right. X equals 3 is right there. So there must be an asymptote that runs like this. It wouldn't logically, if x is 3 right there, run this way. That wouldn't make any sense. Okay? So there's your x equals 3 asymptote. How about your y equals 2 asymptote? Well, here's where y is 2. But then again, it couldn't go up and down. I have to go this way. There we go. Oh, sorry, that's -2. Thank you. -2 down here. There we go. And again, usually with asymptotes, we make them dotted lines. So I'll actually use my fancy dotted line making tool. There. I know you don't. Okay. So there's your vertical and horizontal asymptotes. Now, do you get, if the graph is 1 over x in general, that it's like this? Now, I'm being very loose with that, but I hope you get that there's a dot here and a dot here, and then this gets closer and closer to the asymptote, and so does that, and this will get closer and closer, and so does that. Okay, so how do you tell by looking at one where the vertical and horizontal asymptotes are? Well, I would think of it as where it got moved to. Do you get the start would have been 1 over x, and therefore it would have kind of looked like this, with asymptotes running here and here. And then I moved it. Think about where I moved it. What does this mean? Left 5. And what does this mean? Up 3. If I move this thing left 5 and up 3, not that, move the asymptote. Now, I can put my graph in there to match it, and there we go. So if I just say, what is the horizontal asymptote? The horizontal asymptote depends on this. And I'm wrong. That's the vertical. No, that is a horizontal. That's right. That's a horizontal asymptote. And this is where you get your vertical asymptote from. But the horizontal asymptote's much more complicated than that. It's not just, oh, it got moved up 3. Because that totally depends on the degree of the top and the bottom. Now, I know you learned this in higher algebra. You've learned about horizontal and verticals before. This should be review so far. And this is going to be like something you learned over the course of like 4 days there, and you're going to do it in the course of like 20 minutes here. So yeah, it's going to feel kind of fast, but you have done this before. Now, you may not have used this terminology, but what I'm going to say would have been true in your class. For the horizontal asymptotes, there's either ones that are bigger on the bottom, bigger on top, or same on both. Does this ring a bell? Okay. Maybe your teachers didn't teach it that way. I know some of you did. I can tell by your reaction that some of you learned it that way. And some of you just learned it, well, the same things, but not with the snappy little saying. Bigger on bottom means what? Well, is this one bigger on the bottom just because it's got a 7 here? No, that has nothing to do with it. It's what degree it is on the top and the bottom. To get the top one is degree 2, because if I multiplied it all the way out, I'd have an x squared in it. So just like before, the lead coefficient is smart to find. The top lead coefficient is x squared. The bottom lead coefficient is x squared. Do you get why I would call that a same on both? All right. Because they both have a degree of 2. So that would be a same on both kind. In this case, it's a same on both. So what's the rule for same on boths? Does anybody remember it? Yes. Nope, you're close. There's a different one that's, you're right that one of them's 0. One of them is that there is no asymptotes. And then there's the third case. This is the third case. So there's 3 things that could happen. If it's bigger on bottom, it's y equals the outside, which is usually 0. What it means is there anything outside of my big fraction? Here's my big fraction, the one that's in blue. is there anything outside of the fraction? Because if there is, then the whole thing's going to be moving up. Let's say I put a plus 6 here. Do you get that would move the whole thing up 6? So now your teacher might have just taught you that it's always 0, but that was back in higher algebra, where usually there was nothing added on the outside. If you get an add on the outside like that, moves everything up 6. So the asymptote would have to go up 6. So the bigger on the bottom kind are going to be y equals, it's usually nothing out there. Like this one, there wasn't anything out on the outside of the fraction. So it's, well, then there's like a plus 0, right? That means it moved up 0. That means it's y equals 0. Bigger on top. That's where, let's say this one was squared. Do you get that makes my lead coefficient on this x to the third? So it's bigger on the top. That one's simple. None. There's no bots. You can just remember it's kind of like robot, except it's no bot. If it's a bigger on the top, then there's no asymptotes. So what does that mean again? Let's say that I had this. Y equals x squared over x. Just think for a second. That's bigger on the top, isn't it? Do you get it would also reduce to just y equals x? Do you get that that means a graph that looks like this? Do you think there's any asymptotes in that thing? No, there's no asymptotes if it's bigger on the top. Here's another case of it being bigger on the top and therefore a no bot. There. Now it's got x squared on the top and x on the bottom. It's bigger on top. No bots. Okay? So the bot situation, bigger on top, there's no asymptotes. And lastly is the kind we had originally. This one that I wrote originally is the same on both. If I write its lead coefficients out, or its lead terms out, here and here, the same on both kind have an asymptote. And it'll make you sob to figure it out, because it's the hardest one to figure out. Okay? So they're not that hard. All you have to remember is that it's a ratio of the lead coefficients. There's a 1 in front of both of them, isn't there? So it's y equals 1. It's a ratio of lead coefficient. But in this case, that's a 1. That's the rules for the horizontal asymptotes. There's a lot of them, but there's really only 3 cases. They'll either be bigger on top, in which case there's just none. Bigger on the bottom, which is a bob, Bob is an outsider. You know, like The Outsiders. Wasn't that a book? Yeah. Okay. All right. Yeah, I like that one too. And then lastly, could be a bot, or a sob. And that's where they're the same on top and bottom. We use that one a lot. We like that one on tests because it's the hardest one, and we usually like to throw that in for an R3 kind of a question. All right, so let's check. Oh, one more thing. That was horizontals. Notice I never said anything about verticals in there. The vertical asymptotes come from the bottom. Can you see there's 2 things that would crash this function? 7 and what else? -3. All right. So your homework for tonight is to find vertical and horizontal asymptotes. And one last thing, holes. This right here, do you get how those would cancel? That makes a hole in the graph at -3. 7 is a horizontal asymptote. All right, all I need you to do is the first page of the homework, just the first slide, all. And I put a Dropbox, and I want it Dropboxed before this class begins tomorrow. Okay? Have a great day.